Hello, welcome to MR-CFD. In this video, I'm going to show you how to create the geometry and meshing of this product fluid flow around a wavy tape in a tube. To create the geometry, first we should activate equations, but here if you check equation, click on it, you can see it is created as surface, but you can change it to the mode in which it is not surface. So go to advanced, setting, and uncheck enable constraint, and here you should close Spaceclaim. After closing Spaceclaim, again open it and choose equation in the sketch, and in the left side of the window you can choose what function is going to be your desired function to create the tape. I chose sine wave function, and here a start, end, and a scale should be chosen. So I put the value of 500 as the end of this sine wave. It means that the length of the created function is 500 millimeters. And in the next part, parameters amplitude and period should be set to create the desired tape in this geometry. As you see, when I change the amplitude as A and period as P, the function, as you see, changes. So 2 for amplitude and 8 for period is like this, and it would be the tape that you want. So click on this check mark to complete the sine wave for the tape in this geometry. And now click on the end of the sine wave and draw a line about 10 millimeters, and go to the start of this wave sine, and again draw a line about 10 millimeters. Now go to design, select, and now I want to give thickness to this sine wave. Go to pull tool, click on the edge and pull it as 24 millimeters. Again, do it for these two lines that we created at the end and at the start of the sine wave. This one, and pull this one. So now we have 3 surfaces for the tape inside the tube. I should change the size of pulling. I made a mistake, now I can correct it. To do that, I can click on this edge and back about 13.93, and now this is correct. Here you can spin to see it in different views, and now it's time to give thickness to the surface. So go to pull tool, click on the surface, pull it as actually 0.5 millimeters. And for this surface, and finally for this surface. Yeah, as you see here, we have only one solid. This is the tape that you want to use in our tube. Next step, we should create the tube. Click on this surface, go to plane and click on it. So the plane is created. Go to move and move it as 10 millimeters in Z direction. Now create a sketch on the plane. Try to see your geometry in this view. And now I want to draw a circle from the center of this sketch. The diameter is 30 millimeters. Yes. And now by the line command, draw a line in the center of circle. And now with trim tool, I can remove this one. Okay, exit the sketch mode and try to see the geometry in this view. Now it's time to extrude this surface to create the cylinder, actually semi-cylinder as the tube. I can deactivate the plane, go to pull tool, click on the surface, activate no merge, and now extrude it about 600 millimeters. So it is much more than the desired value. I can change it to 500. No. So again I change it. 550. And go to select. Here we can see the space between the tape and the end of tube. I can check the length or this the distance between them. Yes, it is 23.32 millimeters. So later I can back, and now we have two solids, the tape and the tube, and now I want to split the half of the tape. So go click on this surface, this one, and click on plane to create a plane on this surface. Go to split body and select the tape body, and now cut the one that we don't need, I mean this one that is created, so delete it. And now we have the geometry like this. We can deactivate the plane, and if you zoom in, yes, you see the tape created inside the tube. And now it's time to the distance created between the inlet and the start of the tape. Pull tool, no merge, and actually push it as 10 millimeters. Yes. And do the same for the other surface as the end of tube. Click on surface, no merge, and as you remember, we talked about this distance, and yes, and as you see, again we have two solids. but here the solid inside should be removed. Go to combine, and it asks you to choose a cutter. The three solids are created, and now remove this one and this one. So now we have only one solid, and we could remove the tape from the tube. Actually, now inside the tape is empty, and if you see the geometry in this view, you can see now it is ready. Go to workbench, share. There are no objects to share, so we can close Spaceclaim and go for Ansys Machining. After closing a Spaceclaim, you will see that in workbench window, a green check mark is activated for geometry, and now it's time to transfer it to meshing. To do that, from the list of component system, choose mesh and drag it here. Then drag geometry to this part, and now by double click on mesh, the Ansys Machining window opens for you. After opening Ansys Machining, as you see, this window opens for you and you can see the geometry. First of all, we'll click on mesh and change the physics preference to CFD. And after that, it's time to name different boundaries of the geometry. To do that, from this toolbar, choose face command and click on your desired face, right click on it and create name selection and name it as inlet. When you name a boundary, you can check it from name selection. If you expand it, you can see yes, inlet is created. And now it's time to name outlet. To do that, spin your geometry, zoom in by face command, right click on it and write outlet. Okay, here we have outlet, and the next face is this one. Right click on it, create name selection, name it as outer wall. And the next faces I want to name is these two faces and right click on them, name them as sim or symmetry. And now it's time to name the tape wall or wave walls. To do that, I prefer to right click and select all faces, and by getting Ctrl key on your keyboard, unselect these faces so that all faces for the tape are selected more clearly. So right click, create name selection and name them as wavy walls. Okay, inlet, outlet, outer walls, symmetry and wavy walls. And then we have the whole body. Right click and name it as fluid, or you can name it as interior. Okay, now let's go for giving size to different edges. I start with this edge and this edge at the same time, select them by getting Ctrl key, and from here mesh insert sizing. Yes, two edges are selected, and change the type of element size to number of division. I want to divide them to 50 elements, and next edges I want to give size are this one, and these two ones. So 4 edges are selected, right click, insert sizing. Yes, 4 edges, and here element size is changed to number of division, and I want to divide them to 20. That's it. And next edges are these two small edges. Yes, select both of them and right click, insert sizing. Yes, 2 edges are selected, number of division, and divide them to 2 elements. Yes, so edge sizing are done, and now it's time to give size to the whole body. To do that, choose body command from here and choose the whole body, right click on it, insert sizing. One body is selected, and I want to give element size as 0.0009 meters. And the next step is creating boundary layer, meshing for our geometry. To do that, right click on mesh, insert inflation, and first it asks me to choose the body. Here is the body, and then it asks me to choose boundary scoping method. So I choose this, go to face command, choose this face, and apply it. Change the inflation option to first layer thickness. You should define first layer height, and it is 0.0001. Now let's go for next inflation. Actually, previous inflation is for creating actually a boundary layer on these edges. And now I want to create boundary layer meshing on these 2 edges. To do that, again right click on mesh, insert inflation, and the body is the whole body, apply, and here for boundary method, if I change geometry selection to name selection, I can choose wavy walls and change the option to first layer thickness. Again, the first layer height would be 0.001 meters. Maximum layers is set to 5, and And I forgot to say that to make sure that your meshing is set to the best method, right click on it, insert method, choose whole body, apply, and here change the automatic method to tetrahedron. So I think all setup is done, and now if you right click on mesh and click on generate mesh, the meshing is started, and finally you can see how the meshing is done. So the meshing process is complete, and if you click on mesh you can see how the geometry is meshed beautifully, and if you zoom in you can see how boundary layer meshing is created around these edges and also around the edges for the tape. And if you want to check how many cells are created for the whole meshing, you can see here in the statistics that 2,274,541 cells are created. Okay, the meshing is done. You can close Ansys meshing window and finally transfer it to Ansys Fellow setup. I hope this video is helpful for you. To benefit from MR-CFD services including simulation, consultation, and training, visit our website www.mr-cfd.com or contact us via info@mr-cfd.com.